Hello everyone, welcome to Data Structure and Algorithms. We will learn the following things in this video. What is algorithm and its character, complexities, and different types of algorithms. Let's see what are algorithms in our daily life. Algorithms are not only part of computer programming. In general, the algorithms are needed everywhere in our daily life. For example, when you order a lemonade at hotel, the lemonade maker will prepare it in a step-by-step procedure. First, he will cut the lemon, squeeze the lemon juice, and then he will put the lemon juice into the mug. Now he adds the sugar, then we'll mix the water, and then ice. So we can say that an algorithm is a step-by-step procedure for completing a specific task. In computer science, algorithm is a set of rules to solve a problem by the computer. It contains a finite set of instructions in order to perform the specific task. It is the logic of the problem that can be represented in a flowchart or pseudocode. Remember, algorithm is not a programming code. It represents a logic for any problem. For example, searching a key element in the array. Let's consider an array 43125 and you want to search for an element 2. To achieve the same, we can use the below a step-by-step procedure. In step 1, we will iterate an entire array. In step 2, we can compare a current element with key element. If it is matching, then we can return an element. If not, we can return a message saying element is not found. Now, let's see the characteristics of an algorithm. Every algorithm must satisfy the following properties. These properties can measure the effectiveness of the software. Input. An algorithm should have a specified set of input. The next is output. An algorithm must produce output as a result after processing the input. Finiteness. When algorithm starts running and it must terminate after a finite number of iterations. Definiteness. All instruction sets must be precisely defined. Effectiveness. The steps that are required to produce an output must be feasible with available resources. Let's see big O notation. Complexity of an algorithm can be measured in a big O notation, which means a number of operations executed by the algorithm to return the output. Big O notation represents the upper limits of algorithm cost. In other words, the upper limit is same as the total number of operations required to complete. Big O represents upper bound and big omega represents a lower bound. Let's see what is time complexity. The amount of time required to complete the execution. The time complexity of an algorithm is denoted by a big O notation. Here, big O notation is asymptotic notation to represent the time complexity. The time complexity is mainly calculated by counting the number of steps to produce output, that is, to finish the execution. Space complexity. The amount of space required to solve a problem and produce an output. Similar to the time complexity, space complexity is also represented in big O notation. Space is required for storing a program instruction, storing for a constant value, storing a variable values, and jumping statements. Please like the video and subscribe to our channel if you haven't subscribed yet. Don't forget to hit on bell icon to get notified whenever I post new videos on data structure and algorithms. For code and to learn more about data structure and algorithms, you can install the DS application from the Google Play Store. Thank you for watching.